So this monster of a tube amp is, well, it's a bit of a family heirloom. So my dad, when he was in high school, using whatever money he could scrounge, lunch money and so forth, built this amp. And this would have been like in the 1960s. It didn't look like this exactly. I've since sort of rebuilt the chassis and repainted it and rebuilt a lot of the circuitry. I'll throw a picture up of what it looked like when I got it. So my dad built this. I never saw it used growing up, but growing up I would occasionally see it. It was in the garage, up in the loft for years and years. And when I started getting back into tube amps in the around early 2000s, he's like, "Here, you want this?" So he handed it to me, and I put it in my basement, and it sat there for years and years and years, and finally I decided to tear into it and see if I can get it going again. So the chassis was really rough and had lots of extra holes in it for various things that came and went, so my retrofitting of the chassis sort of made use of holes that were already there or modified in various ways, or tried to cover them up. And the surface was really rough. It had some sort of textured finish that was peeling everywhere, so I primed it and painted it with this sort of splatter finish, which kind of covers up the surface imperfections. It looks pretty nice. The only thing I don't like about it is it's got a real rough texture, and it's hard to clean the dust off of it. So I rebuilt the amp initially following the original design of the circuit as it was, and my dad told me that he built this following a schematic he found in a magazine. It's another Williamson style push-pull amplifier with an extra stage in it. So it's the input stage is a 6SN7 GT. The one half is used as the input gain, and the other half is used as the phase splitter in a concertina style phase splitter. This is a 6BL7, I believe, and it is the driver for the output tubes, and it also has some gain in the way that it's set up, and overall the amp has way too much gains, I've found. So I'm going to be changing the circuit into something completely different, but my initial rebuild, I wanted to get it going exactly as it was, just for nostalgic purposes, and I pretty much set it aside and haven't used it since. The output tubes are unobtainium. They're 8417s. 8417s are an interesting tube. They're a power tube. They came out really towards the end of the tube era. I think it was one of RCA's last designs for power tubes. They were used in some other commercial amplifiers, some instrument amplifiers. They're basically impossible to find now, and most of those amps are either gone or they've been retrofitted and modified to use KT88 or more commonly available tubes, 6550s. They don't put out quite as much power, but at least they work. So yeah, so originally he built this amp, he pushed the specs right to the edge, and he was getting about 100 watts per channel out of this sucker. When I rebuilt it, I sort of throttled things back. I brought the plate voltages down to something a little more reasonable. I don't need 100 watts per channel, so it's more like 60, 75 watts per channel now, the way I have it set up, which is more than enough for me. So yeah, I added a bunch of switches and meters to kind of fill in all the various holes that were in the chassis and whatnot. I made holes for the meters. These are, so there's a DC regulated screen supply under here for the output tubes. And I kind of over-designed it and made them adjustable. You can adjust them through these holes, and then this tells you the voltage in hundreds of volts. And I did that to future-proof it, so I have some sort of plans how I want the topology to be later on. And so I built this screen supply to cover up a big gaping hole in the chassis right there where there was a transformer. And this is just a heatsink for the regulators. These are the output transformers, obviously. And right here there was this, when I got it, there was this little stand here with a small transformer. It was just a 6.3 volt heater transformer and a fan behind it to blow air over it, because apparently it ran hot. Originally, this was where the main power transformer was, which is why it had such a big hole and got covered up. And he went through several of those, burning them out because he was running it so hot. And eventually he just ran it with no transformer at all. So this wooden box is the replacement power transformer that he used in the end. There was no transformer in here at all. It was just a couple of diodes and a bunch of capacitors. It plugged directly into the mains. Very dangerous, but plenty of power, that's for sure. I never ran it like that. I got a transformer for it, a toroidal one that's under the chassis, which I'll talk about later. This is the small transformer for the screen supply. The transformer I got for the plates and the heaters didn't have another winding that I could use for the screens, and I didn't want to regulate down all the way from 300, 400 volts, so I got a little guy here that just does the screens. These are the filter caps for the main plate supplies. It's a split supply. It's a single transformer with split rectifiers and filtering, and then this is just the cap for the screen supply. These switches are to switch between triode and pentode mode. It's not really safe to run these tubes in triode. You need to bring the screens down. You can't tie the screens to the plate and run them at 400 volts. You'll melt the screens. So I don't throw the switch for these particular tubes. These switches here on either side are to pick which output tube you're looking at on the meter here. So this is measuring the tube current, and you just switch back and forth to check them, and you adjust them through these holes here. And then again, these are the screen supplies. There's a split supply there as well, and they're adjustable through here. That's just the power switch. So here's the underside of this amp. As you can see, there's quite a few things going on. Most of the circuitry and components under here are new. There are some that are still left from when it was originally built in the 60s. Some of these resistors here, basically a lot of the design of the original preamp stage and phase splitter I left just because I knew I'd be changing them anyway, so I just decided to leave. The components that were there, they were still in decent enough shape. The carbon comp resistors and everything, they measured reasonably close, so I just left them. This giant thing right here is the power transformer that's providing supplies for the all the plate voltages on the tubes and also the heaters. It's by Antec. They're a small outfit that's winds these toroidal transformers. They're intended for tube amps, but they're really fairly inexpensive. I mean, as tube amp power transformers go, it's pretty hard to beat what they're offering as far as power for the pound, for the dollar, I mean. And they're toroidal, so they're compact and they don't leak a whole lot of flux, though, as I'll talk about later, there's still some issues. This is a CLC filter, so there's a 50 microfarad capacitor, then this 1 Henry choke, and then a 210 or something microfarad cap. That gets me about 420 volts of plate voltage, which is more than enough for my needs. I wanted that to be low enough that I could change the design of this amp and use, you know, modern KT88s, which are not safe to take too far over 400 volts these days. Just they're not constructed with enough precision to handle much more than that. So the rectifiers are some hex threads, and they're down underneath that sort of little panel that you saw towards the back of the amp. They're underneath this toroidal transformer here. There's a steel bracket that I put in to support this, and right behind that is where all the diodes and stuff are, and they're mounted to that upper plate. This board down here is the power supply for the screens. It's a 100-volt transformer, that little guy that was on the other side, and so this is just the filtering for that. And then the supply from here goes to this board over here, which is the regulators for the screen supplies. It's a LM317 floating at a high voltage by this high power BJT here. And these little pots are just tweaks for the meters, just to calibrate them. The actual voltage is set by these two pots here, which are adjustable from the front. These pots here are just they're called hum pots. All the heaters are AC, and you need to center the AC relative to the ground, the signal ground, to sort of cancel out the hum, and you just tweak these guys to make that perfect. So the output tubes come right off the main plate supply, like I said, about 415 or so volts. And then, you know, as is typical, you step down through series resistors to drop the plate voltage lower and lower for the various stages. And these blue caps are just to keep those voltages steady. So this one here is for the first stage, which is for the driver, the output tube driver stage, and then this one here is for the input section and phase splitter. These switches these are the back of the switches for the triode pentode mode switch. These resistors are just the screen series resistors, and it switches between this orange wire, which is coming off the screen supply, and another wire that goes straight to the plates. Like I said, it's not safe to run the 8417 in triode mode. These are the bias adjustments here. Just the back of the pots, there's a little bracket they sit on, and these just keep the voltages steady. So these are all those meters you saw on the front panel along the top here. These are the bias checking meters, and you might be able to see there's a little blue trim right there. That's just to calibrate the meter. So the meters get their reading off the cathode. There's a 10 ohm resistor on each tube from the cathode to ground, and then the meter just measures across that. So yeah, like I said, this is the original circuit topology with the input phase splitter, driver stage, and then a pair of pentodes in push-pull configuration. My intention is to, like I said, this thing has way too much gain, and also I'm picking up a lot of hum. The amp is dead quiet when the inputs are shorted, but when I connect the source or even just leave it unconnected, it picks up tons of hum. And I'm pretty sure it's because the steel chassis is being excited by the proximity of this power transformer. Toroidal transformers are pretty good about not leaking, but I've also got these chokes sitting here. So I suspect the chassis has got currents flowing through it just from the AC coupling. And with the inputs way at the back here, they're actually right here and here, and I've got shielded cable going to the front, but I know that they are picking up hum just from that length, so I could just move the inputs to this side. But there's more to it than that. I think I need to do something about the coupling and either figure out if it's just the chokes doing most of it, or if it's the transformer, I won't be able to have this transformer in here. I'll have to move it outside the chassis to solve the problem, which is unfortunate, and that's part of the reason why this amp has sort of been sitting after I rebuilt it. It's just kind of been sitting in my shop for the past several years because I haven't decided what I want to do about it. And I also want to change the topology, like I said, with just a Williamson type setup and pentodes for the power output. These output transformers don't even have ultralinear taps. What I was planning to do was to switch to a different topology, sort of a hybrid topology. There was a cool thread on DIY Audio of a guy who was building a KT88 hybrid amp along with George Anderson, the guy who runs TubeLab. You may have seen my other video about the Simple SE. Yeah, it's the same guy. So he's all into using FETs to drive tube grids, and if you do that, you're able to drive the tubes out of Class A into Class B, where they'll start drawing grid current. And usually when you do that in a tube amp, you start having issues with the driver stage going out of its ideal conditions, just because of DC blocking through the various stages through the coupling capacitors and whatnot, and you charge up the coupling capacitors, and it causes everything to go out of whack, and the amp sounds like garbage. So by using a solid state driver right on the grids, you can do all kinds of tricks, and you can actually drive the tubes the way they're designed to be driven and get tons of power out of them, even though you may not be running the full spec plate voltages. There's also other things you can do, like screen drive and things like that. But I was just going to go with the regular hybrid drive, using a long-tailed pair type phase splitter, which would reduce the gain as well. So anyway, I know that's a lot of terminology and whatnot, but the tube socket setup is perfect for that. And like I said, I left all the original circuitry here, which I intend to just change out and when I switch to the new design. And that was the reason also why I built this big supply for the screens, because I need that supply for the FETs that will be driving the output tubes. And then there's an extra bit of heatsink here where those drivers would be mounted. And so that's the long-term plan, but for now it's just kind of sitting around because it has a hum issue, which kind of makes it not super usable. So yeah, this is my Monster Beast amp. I just call it Dad's amp because it's my dad's, or it was at least. Like I said, this thing has just copious amounts of power. It's a rock and roll amp because it's a pure pentode. It's not the most linear amp, but boy, it can rock. So yeah, I can put out the bass no problem with my Boston Acoustic A60s here. I could blow them straight off the shelf. But anyway, so yeah, let's take it for a spin. And Ian from Singapore, this one's for you, buddy.
Give you